Hi there, this is GCSE Waves Lesson 7, and this is blackbody radiation and colour. What are black bodies and why do they appear black? And how does light behave and how do we see different colours? So just a quick recap on the EM spectrum. So radio waves, microwaves, infrared, visible, UV, X-ray, gamma, different frequency ranges at the bottom, an approximate scale of wavelength, buildings, humans, butterflies and so on. If you need to get any of that down, obviously just pause at any point. Alright, let's keep going. So visible light. So colours are narrow bands of wavelengths in the visible spectrum. So as you can see, the longer wavelengths are the red side and the shorter wavelengths as we get to the blue side, which is exactly the same as the EM spectrum. Radio waves are longest wavelengths, as you can see at the top. As you move to the right, gamma rays really short wavelengths. Same with the colours, so red are longer, blue are shorter in terms of the wavelength. So how do we see things? So light is emitted by certain objects. Light reflects off objects and is taken into the eyes. So that's simple. So three things can happen with light. And they are reflection, absorption, and transmission. So reflection, it'll reflect off the object, absorption, it'll be absorbed into the object, and transmission passes through the object. So the colour of an object is related to the reflection, absorption, and transmission of different wavelengths of light by the object itself. Now there's different types of surfaces. So we'll look at this in more detail in the next lesson that's on reflection. So mirrors and rough surfaces. So the surface of mirrors are very smooth. This allows light to reflect perfectly off of it. When rough surfaces don't reflect light neatly, this means the reflection cannot be formed. So obviously we don't get reflections off of everything, it's just nice smooth surfaces. And these have got special names which we'll discuss in the next lesson. So white light. White light is a mixture of all the colours of the visible spectrum. So this would be a prism. You might have done this at school. Shine white light into a prism, and on the right hand side you'll get like a rainbow effect where the one side is red, it'll go through the spectrum, the other side will be the blue side. So colour of objects. So the colour of an object, of an opaque object, is determined by opaque. Obviously you've got transparent, which is see-through, translucent like glass for example, which is partially see-through. Opaque is, normal everyday solid objects. So the colour of an opaque object is determined by which wavelengths of light are more strongly reflected. So if you see something and it's yellow, it's because if you shine white light on it, it's because the yellow part of the spectrum is being reflected more strongly and the other colours are being absorbed. So blackbody objects. So blackbody objects absorb all wavelengths of visible light. So when light shined on them, they absorb all the wavelengths of light, so they don't reflect anything off, therefore they will appear black. And white objects, they reflect all wavelengths of light. So every little piece of light, the white light that shines on it, all the individual wavelengths will be reflected, so you'll still see white. Right, so here's a image that might help you realise. So Roy G. Biv, well, the indigo is missing, but you've got red, orange, yellow, green, blue, and violet in this case. So if you shine all those wavelengths of light at a blue object, the blue object will absorb more strongly all wavelengths of light aside from blue, which it will reflect, therefore the object appears blue. Red object, same again, so you shine light on it, white light, and it will reflect strongly the red wavelengths, therefore the object appears red. So a white object, if you shine red light at it, now white, remember, reflects all wavelengths of light, so if you shine red light on a white object, the red will be reflected, it will appear red. And then black, remember a black body absorbs all wavelengths, so it will still appear black. All right, let's do some questions then. So I just want you to have a think about this one. So you can put 1 to 6 and then put down what you think will happen. So you want to pause and do that, and then I'll take you through the answers. So first of all, a blue object under white light would still appear blue. Remember, white reflects all wavelengths of light, so if you shine blue on it, the blue will still be reflected. A red object under red light will still appear red. Red will be reflected off of the red object, so it will obviously correctly appear red. What about a black object under white light? So that'll still be black, because remember, black objects absorb all wavelengths of light, so all of the light will be absorbed and the object will appear black. How about a blue object under green light? Well, that'll appear black as well. So blue objects reflect strongly blue wavelengths of light, so when you shine green on it, the green will be absorbed. There's no blue light being reflected, so the object will appear black. A white object under white light will still appear white. All the wavelengths of light will be reflected at once, so it'll still appear white. And the last one, a white object under yellow light will appear yellow. So yellow light's the only light that's been reflected. White does that, reflects everything, so object will appear yellow. Hopefully that went okay, pretty straightforward. Thanks for watching, and I'll speak to you soon.